Okay, so in this page, we plan to show you the motivation to start the ER model by illustrating the key steps in building a DB application. Here, the DB application denotes a database application. Firstly, when we start a project or application, we need to select a application domain. This domain generally is the topic or which area you plan to do. For example, if you plan to develop a social network like Facebook, then you can pick the Facebook as a domain, right, or the social media as a domain. Otherwise, if you want to do either e-commerce, you can develop a website very similar to Amazon, then you pick this domain, right? And after you pick the domain, the next step will be doing the conceptual designing. Generally, you need to discuss about what to model in this application domain. What to model means what kinds of information are there you plan to model. For example, if we do the e-commerce website, we need to model all the products, all the customs, all the transaction relationship between the custom and the product, and etc. So when you have the discussion and the brainstorming with the teammates, you will have some consensus and some discussion results, and you plan to write them down. You need to have a language to write them down, right? You cannot write in plain English. That's not enough. And we need to have a modeling language to express what you have or what you want. And the ER model is the most popular of such languages for you to express your ideas. And the output of the ER model will be a very simple diagram. We call it as an ER diagram of the application domain. Yeah, this is step 1. You can see step 1 is the initial stage for your project as well as for the application. And in the following steps, we need to pick a type of DBMS. Maybe in this course and in our project for this course, we have no choices. We have to use this relational DBMS as our database systems, which is also the main focus of this course, and it is also very popular nowadays in the industry. But for your future career, generally you can choose any kinds of DBMS for your application. Maybe you can choose MongoDB as well, but it is not for this course. And then in the following steps, we need to translate the ER diagram into some language that the machine can understand. You can see the ER diagram is something which is very easy for human beings to draw. However, for machine, it's very hard to process the ER diagram. Then we need to do a translation from the ER design to some relational like schemas. We will teach how to do the translation by introducing a set of rules to translate the ER diagram into relational schema. And we can also have a set of schema refinement rules to transform the above schemas into very good ones. And in step 3, we will introduce the relational algebra, relational design, as well as the relational model for you. Then at this point, you can have very good relational schema on your paper. And the following things will be developing in your machine with some programming language. So the subsequent steps will include, the first one will be implementing your relational DBMS by using some language like SQL for building the DBMS. Because ordinary user cannot interact with database systems directly, it will be very complicated. Then we have to write some program for us to handle the DBMS, to do the data management. We can write our program in C++, in Java, in PHP, and Python, and some other language you prefer to handle the interaction and also take care of things the database systems cannot do. This step is called implementation of your database system for the specific application you choose. You can see in the following steps, they are about the engineering things, and the steps before, they are focused on the design part. So the first thing we need to do is to learn the ER model so we can learn how to design our application in a professional way. So by showing the steps in building a DB application, I hope we can provide you with enough motivation to learn on the ER model. Okay, so first we want to introduce the ER model and where the ER model comes from. So ER model is a language to specify what information a database must hold and what are the relationships among the components of that information. It denotes the entities and the relationships. And we need to cover lots of things in this section, include some basic constructs, the constraints. We can set as design principles. We introduce them one by one in this section in very details. And this model is originates from a paper proposed by Peter Chen in 1976. So the paper is called the Entity Relationship Model Toward a Unified View of Data, which is accepted by the ACM Transactional Database System, or TODS. It is also one of the most cited papers in computer science. I think you can search the paper on the web by using Google, and you can find lots of citation on this paper.
In this lecture, due to the limited time, we will not be able to introduce the ER model in detail, so you can refer to the previous lectures on undergraduate database for more information. So we know in the ER model we have so many different constraints. What is a constraint? Formal constraint denotes an assertion about the database that must be true all the time. So the constraint can be very different, and we have different constraints in database systems, and they can be very different from each other. The constraint can be part of the database schema, and it will be very important in the database design. According to our previous lecture, we remind you every time whenever you draw a relationship, ask yourself what is the constraint of the relationship: one-to-one, one-to-many, or many-to-many. Here we will cover more constraints. The first one will be keys. General keys will be on some entities. So for example, for a person as an entity, we can use some attributes like a social security number as a key for it, for a person entity, because this social security number can uniquely identify a person. Then what is a key? We will introduce the key, the definition later, because it will be very complicated. So far you can understand in this way. So the key can be one or a combination of multiple attributes that together will uniquely identify some data tuples. For example, the SSN will be a key for a person. Your FSU ID will be a key for a student in FSU. Right. Besides the key, we also have some other constraints, like a single value constraint. For example, in the real world, a person can have only one father. We should avoid inserting multiple fathers for a person, right? Another important constraint we introduce here is called referential integrated constraint. So it denotes some entity should exist whenever we reference it. So for example, if we look for a component, in other words, we create one relation between employee and components. Once we add some relationship between you and a component, then this component should exist in the database system. We cannot connect you with some component non-exist. We cannot connect you with some non-existing components. Also, we have some domain constraint. A person's age should be between 0 and 150. We cannot have a person's age which is -10, something like this, right? We can also have some other constraints. For example, we can set a limit for the enrolled number of students in a course, like 60 students. So constraint can be very important. It is also one part in the database design. Therefore, when you are drawing your ER diagram, besides the constraint we learned for the relationships, you should also ask yourself, does this ER model has any other constraint or not? You also wonder why we should have this constraint. The main reason is because the real world can be very complicated, and the information or data we can get from the real world has different semantic meanings. And when we involve the real world or applications with database systems, we should be able to keep as much this semantic information as possible. Therefore, with the constraints, we can give more semantics to a database design. For keys, it will also allow us to refer to some entities with some simple attributes. Like I can use an SSN refer to a person. Instead of describing all the attributes for a person, we can just use his SSN in reference to the person. It will be much more efficient in the storage as well as data lookup. So that in reference to a person, besides SSN, can we have any other keys? Someone may say we can use a name as a key. However, in the real world, maybe the name is not enough. So at the bottom, we show an example about Michael Jordan. When we talk about Michael Jordan, I think for you, most of you will assume we're talking about the first person. The basketball player is very famous, right? However, in the near future, if you plan to go to a graduate school and do research on machine learning or data mining, then when we're talking about Michael Jordan, it is highly likely that we are talking about the second person. He is a professor from UC Berkeley. So, in other words, in referencing to a person, maybe the name alone is not enough, and we can combine the name as well as his employer. Together, this can serve a key for the person as well. Therefore, you can see for the key in referencing to entity, we have different options. Besides SSN, we can also use the name combining employer as another key as well. Of course, you can also find some other keys, like passport number. It's a different key. So you can see we have different choices of keys. We will mention this later as we are talking about relational algebra in the near future. So when we join a diagram, we need to highlight its key for the entities. So for example, in this page we show two entities. The first one is about product. The product entity has two attributes, price, name, and category. For the product, maybe the name alone is not enough to serve as a key to differentiate different products. Therefore, we propose to combine them with category, and together can serve as a key for products. To highlight the other keys, so we can underline them in the category together in the diagram. So for the person, according to the previous page, we have different choices to define key for the person entity. Besides the SSN, we can also use the name with a choice that together can also serve as a key for a person as well. However, for the diagram, we have no formal way to specify multiple keys. Therefore, we have to choose one key for the person entity. Here we choose use SSN and we underline it to highlight it as the key. If you don't know SSN, you can also remove the underline here and also add an underline to them with a choice, and together can also serve as a key for a person. So there will be different choices, and you can decide which one you like or which one works better for you. So every entity must have a key. Key is very important in the entities. So whenever you draw an entity in the diagram, ask yourself what is the key for the entity. You may wonder why key is very important. The main reason is because we need to store the data in our database tables. Let's assume we translate the diagram into relations and further create some tables to store the data. Now for a person, when we store all the person data into the tables, how can we locate one specific person meeting our search requirements? We need to have a key in reference to a specific person, right? This key can serve as an ID of this data tuples or pairs in our tables. So the key is very important. As we mentioned, a key can consist of more than one attribute. Sometimes one attribute is enough. However, sometimes we need to use multiple attributes. And the largest key we can create for an entity will be the combination of all the attributes of an entity. It is also allowed, right? We can use all the attributes of an entity serve as a key. You can also uniquely identify a data tuple in our tables. So in other words, there can be more than one key for an entity set, and among all these candidate keys, one key will be designed as a primary key. Therefore, besides the constraint on the relationships, you also need to pay attention to the keys on the entities. Whenever you draw an entity, ask yourself what is the key on this entity.